Hi, welcome back to another NIME's hands-on session on image classification. This workflow demonstrates the image classification with examples of recognizing cats and images of cats and dogs. The model that is being used in this workflow is Convolutional Neural Network, which is the most adapted architecture to deal with image data. So, without any further ado, let's get started. So the workflow is basically divided into three parts. The first one is reading the and processing the images, and the second one is the building the convolutional neural network, and the final one is going to be training the neural network and executing to see the evaluating the model performance. Let's start with the first process of reading the images and pre-processing them for the next steps. So the first node in the process is the list of files and folders node. This will help us to uh, refer all the images in the folders and files that we would want to use for the image processing. So for now we have a folder where all our images of cats and dogs have been collected, and then that file has those folder has been referred using the list of files and folders node. And then the path to strings node will help us to convert the file path into a string, because the image processing nodes will need the input of the image in the string format. So the path to string node will help us to convert the path name into a string. And then by using a rule engine, we are actually trying to label the data. So the as you see, the images have the file name as cat and dogs. So we just want to use the file name to use this file name to label our data. So by using a rule engine, and by writing a simple rule of looking at the name of the cat in the location or the file name, which is the string, and we are trying to classify the data. So this is what is being done. So as part after the rule engine is being executed, we see that a new class has been in class field has been introduced into the data table. So this is our original part. This is the string format that got converted, and then now we have labeled the data with the cats and dogs as per the rule. Okay, now this is being done. Now by using the row sampler, we will select a subset of images that we will be using for the image processing. And the rule engine, this rule engine will help us to encode the class, because the class is in the string format. Now we want to label convert this encode this labels from, like, no, any class which is identified as cat is termed as encoded as 1, and then the dogs will be encoded as 0. So this is by using this simple rule we are trying to encode the class which is a categorical variable into a numerical variable. So if we look at the output at this point, we see that now a new numerical class is encoded with cat as 1 and dog as 0. By using the image reader table, we are trying to read all the images into the KNIME image table format. So for this reading, we can configure the way we would want to read this by using the metadata image factory and the pixel type. So for now, we are using the automatic, so it can pick the type through which the image will be read in the pixel format. So once this is done, if we look at the table reader, we would have read all the cats and dogs images into the NIME's image table, and then they're already classified and they're also encoded. Okay, so this is the data that we have as of now in the NIME's image table. Now, the image calculator node will help us to do mathematical operations on the images, and the image resizer will help us to fix the image size to a standard format, like how we would want it to be, 150 by 150 pixels. So there is one standard format of the image size. So when we use these images for the neural network, they are saved or in the same dimension. So this is being done, and then if we look at the output at this point of time, we will see all the image sizes have been converted to a standard size. So you see, though you can't see the images, but then the size is of the same 150 by 150. And the column filter we are using to remove the unused variables, because now we have the image collected, we have a class, we have encoded the class, and we don't need path a variable anymore. So we are excluding the path. So now the data is being processed, and now that is the next step in the our machine learning process of this convolutional network would be first like partitioning the data into training and testing, just like any other machine learning model that we have been seeing so far in our series, machine learning series, nine machine learning series. So by using the table partitioner, we are partitioning the data set, which is now in the image format, into 80-20 set, with the first partition being the 80 set, which will be used for training the images, and the second partition will be used for the testing the machine learning model. So this is what is being done so far, and now let us see the next step of defining the network architecture at this point. So now let's come to the second part of defining the network architecture for the convolutional neural network. So for now, so far we have done is that we have created an image data set containing bunch of images of cats and dogs, and then we have labeled them and resized our images so that they can be passed on to the neural network. Okay, so that when we train this model with the images of cats and dogs, if any new images of cats and dogs are given to the model, it will be able to predict. And then for this, we are using a machine learning algorithm called convolutional neural networks. So let's see how this gets built now. So the first step in the and then, as you know, the convolutional neural network is the most popular approach model that is used for dealing with the images. Okay, now here let's start with the first node, which is the Keras input node. Here, when we have configured our image resizer, we have configured that with a pixel size of 150 by 150, and with the three channels. So we will use the same configuration to start our input layer. So here we configure the shape of the input layer with 150 by 150 pixels and with three channels. And then the next the node in this series is the convolutional 2D layer. This creates our first convolutional layer, and then we will be able to configure the filter size, which is like 3 by 3 strides and padding, and also the activation function, which will help us to understand the which will help the model to actually process the features in the images. And then comes the max pooling 2D layer. The max pooling 2D layer creates the first down the image size. Okay, now the pool size here is also 2 by 2, because we are applying a 2 by 2 filter even for the convolutional layer. And then we will repeat these two layers again, because the convolutional layer will help us to learn the deeper features and the more complex features of the image. So we are repeating the convolutional layer once again, and also reducing the size by using a pooling layer. This will help us to compress the data, and which will help in reducing the computational expense. Okay, and then comes the Keras flatten layer, which will reduces the shape of our vector into a single dimension, into a single dimension. So far these were like not 2D layer, right? So now the flatten layer converts the 2D features map into a 1D vector for the dense layers. So the dense layer connects all the neurons to learn the relationship and make the predictions. So this is the job of the dense layer. And the dropout layer will help us to drop some of the neurons during the training to prevent any kind of overfitting. And the final dense layer produces the final classification of prediction of output. So, and then this is going to be a binary classification by using a sigmoid function. So the activation function that we are using is a sigmoid function, And then the sigmoid function will help us to classify if the image is of uh, 1 means it is a cat, and then 0 means it's a dog. So this is how our network architecture has been built, which will be now used for the Keras network learner. So our final step is to train and evaluate the convolutional neural network, for which we will be using the Keras network learner. For this Keras network learner, we will pass the Keras dense layer as one input, and also the training data of the our image data of cats and dogs, the 80% of data that we are passing to the network learner. Once the learning is done, because now we have executed all these nodes, and then you see the nodes are in green status, we pass on the output of the learner to the executor node. Here we see how the model has learned with help of the test data. So that is why from the test data partition is also being passed to the network executor. And then this is also executed, and then as you see, the output of this function of the learner will be something like this. So it has evaluated on the test data the 20%, which are like 70 images. What is the class? And it has identified the class of each of them. Now using the scorer, we are going to see the model performance. And if we look at the statistics, the we see a 67% of accuracy on how the model has learned. So to summarize, what we have done so far is that, so first we have taken a set of images of cats and dogs, and then we have done some kind of image pre-processing in pre-processing, and also the label the data, resize the images so that they are available, they are ready for the neural network, and then we also created a convolutional network architecture where we have created a 2D vectors of to learn 2D vectors to learn about the features of the images, and then we use the max pooling to reduce to compress the image data, and then we have used the multiple layers of convolution layers and multiple pooling layers to actually extract the complex features of the images, and also to reduce the and compress the size of the image. And then we have converted that 2D vector into a 1D vector by using the flatten layer, and then we have used the dense layer and dropout layer to avoid any kind of overfitting. And finally we use this sigmoid function to calculate to do the binary classification. So once this architecture is passed to the neural network along with the test data, the convolutional neural network has been trained, and then by using the test data we have evaluated, and by using the scorer we have looked at the performance of the model, and as we see it has got 67% of accuracy. So this is how we are able to see how the machine is able to learn from the images as well by using the convolutional neural network. Thank you for watching. See you in the next video.